It is now my distinct privilege to introduce today's distinguished McCord Lecturer, Karel Janeček. We are incredibly fortunate to have Karel as the 48th McCord Lecturer. He's a one-of-a-kind leader who can speak to the challenges and opportunities of today's world. He was born in Pilsen of the former Czechoslovakia, today known as the Czech Republic. From an early age, Karel was fascinated by numbers. He pursued his passion in mathematics by studying at Charles University's Faculty of Mathematics and Physics, where he specialized in probability theory and mathematical statistics. Karel then became aware of Bradley University after meeting Dr. Arlen Rubash, who later became his close mentor. As you already heard, Karel graduated from Bradley University with his MBA in finance in 1997, and later earned his PhD in financial mathematics at Carnegie Mellon University. One of my favorite stories that I've learned about Karel comes from his time spent right here in Peoria, Illinois. While attending Bradley, his friend told him that it was possible to make money by counting cards and blackjack at casinos. Considering that Karel was only earning about $121 per month from his scholarship at the time, it's easy to see why a college student would be enticed by such a lucrative strategy. So he tried his hand, literally, at the Paradise Casino. Karel also created a simulation software for advantage play in blackjack that he called Statistical Blackjack Analyzer, or SBA, which he started selling to blackjack players. Yep. Indeed, Karel became so good at counting cards and consistently winning in casinos that he was ultimately added to the Griffin's Book, an infamous registry of players that casinos ban from playing blackjack on their premises. Now, if you think this story reads like a script straight out of Hollywood, the rest of Karel's achievements are no less dazzling. He has built a career defined by bold ideas and real-world impact. Karel founded the firm RSJ Algorithmic Trading, which quickly became an official market maker on the London Derivatives Exchange, and over time ranked among the highest and largest trading firms in the world, thus turning Mr. Janeček into the Czech Republic's first self-made billionaire, with a B. In an effort to alleviate systemic corruption and redefine democracy among the people, he created the D21 voting method, an innovative system that gives people more nuanced, expressive voting power and is now used in cities, organizations, and institutions worldwide. Karel's passions also extend philanthropically with efforts to generously help those in need. He created the Endowment Fund for Help to build a trustworthy platform to provide aid for those who need it most. After his positive experiences with the Endowment Fund, he later founded the Karel Janeček Foundation, which funds education, science, anti-corruption efforts, and civic engagement initiatives. If all of this weren't enough, just a few years ago, Karel decided he would run for president of the Czech Republic. It's quite a New Year's resolution. Although his bid for president didn't come to fruition, Karel nevertheless was reaffirmed in his efforts to continue making a positive impact on social change. And last but certainly not least, in addition to his many incredible professional achievements, Karel is also a devoted husband and father, something he considers one of the most important areas of focus in his life. Together, these achievements position Karel as a rare figure, someone who moves fluidly between math, money, and societal change, all while leaving a lasting imprint on all three. Ladies and gentlemen, we are very fortunate to have Karel Janeček with us today. Please help me welcome him to the stage.
Thank you. Good afternoon, ladies and gentlemen. Let me thank you so much for this warm welcome back to Bradley University. Thank to Charlie and Jim and others. It was really, I'm so glad to be here. I had a great evening yesterday and have had great day today. And also thank you for the very nice introduction. Yes, it is true. Lecture was a very important part of my student life and the software. So now it's over. But now I do other things, and this will be the subject, one of the areas that I focus on, will be subject of today's talk. And it will be about art in mathematics. In fact, I will be speaking about something that I wouldn't believe myself when I was a graduate student here. In fact, until my 34 years old, I was a skeptic. I believe that all we are created, or we just are random evolution. And that changed. And for me, it was a total breakup in my philosophy, in my paradigm, when I saw that things are happening not totally randomly, in synchronicities, and I had to totally change my worldview. And there started the journey, part of which I'm happy to share with you. As a maybe first introduction, I will not spend much time on it, but yes, I have been a mathematician from my early childhood. From what I remember, 3-4 years, I loved numbers and math, and the first thing what I remember was so intrigued when I was asking about negative numbers, because I saw the temperature, thermometer, and I was asking my father what are the negative things. So that I remember as a, 4-year-old kid, and I loved that. And I always continued with my mathematics career, playing games. That's why I was immediately jumped on the blackjack here. But at the same time, I believe that all the things that we are facing are random, which is not totally consistent. But for me, the Occama razor, the most simple explanation of our reality would be that we have unlimited number of trials, and out of this unlimited number of trials, we are the lucky observers that are here. That's, if you know, Stephen Hawking called this spontaneous creation. And then I realized that this is not the case. And I will show you a proof, I dare to say a statistical, mathematical proof what we can find in mathematics. And I will argue why this cannot be by pure random. Meaning that when number 1 was created, there must have been more to it than just pure randomness. And that happened, in year 2008, 2007, I saw these different synchronicities happening, and as I already have mentioned, it just started to break my belief. And because I studied probability theory, I designed my own test to confirm that myself. So the time started a journey of numbers, and because things are not completely random in our creation, I believe. Then I was thinking about what could be a meaning of numbers. There could be some deeper meaning, especially about integer numbers. And that one evening, I had a vision of number 12, or let's say dodecahedron. Right? We have 5 Platonic solids. It's 3D. One of them, perhaps the most interesting one, is dodecahedron, which are 12 pentagons symmetrically around. And I had the vision this one evening that dodecahedron is connected to our rational thinking, that our mind is reflected in this Platonic solid. That was fun. But the next day I was intrigued because I looked at the internet and I found that according to Plato, dodecahedron represents ether. So the other Platonic solids represents water, air, fire, and so on. So I started to delve into that because it was so interesting, and I could see, I could find so many things about number 12, how it's connected to philosophy, to Christianity, in fact, to also biology and other things. But the more I analyzed that, I was starting to come to number 21, its mirror, as being the special number. Even perhaps in some sense more than 12, or in fact the pair 12 and 21 being so unique. We have that in different aspects of human life, including psychology, for example. You might know that it is being said psychologically that one needs 21 days to get rid of habits, or just to delve into some habits. So now 21 is from many aspects. And also 21 is, I forgot the English term. Anyway, the answer to the question of life, universe, and itself, Hitchhiker's Guide to Galaxy, right? So after 7.5 million years, DeepMind concluded that the answer to the unknown question is 2 times 21. And I say it just made a small error multiplying by 2. Okay, so. Now, because I figured and I saw the specialty of these numbers. In fact, I encoded that by publicly saying on one conference, I think 2015 in the Czech Republic, that 21 is the number of our universe, being said like in let's say artistic point of view. So so I said that. The reason why I'm stressing is that this is fixed. We have fixed 12 and 21. So all that follows is out of sample. It's not anything re-engineered after we find it. Yeah? So that's important from a statistical point of view. And because I love numbers, and I have already had several foundations, I decided to use the numbers. So my foundation would not give a price of 200,000, but rather would give 21 to the fourth power, 194481. Or instead of 250,000 Czech crowns, it would be 12 to fifth power, which is 248832. Or nice number, 12 times 21 squared, close to 60,000. So and this is actually I later found it's a good strategy. Unintendedly, but turned out to be a great marketing tool because people would see, there's a foundation gives a price, and the price is 12 to the fifth power. So then people would say, what does it mean? And they will have to think how to do powers. So there is an education effect, and also there is the effect of attention. So it has this direct good consequences, and even partially educating people. Again, this I am saying up front. It is already given, the strategy of using these numbers. Or times. I would do business meeting not at 2 p.m., but 2:21 or 12:21, things like that. So great. So we have, what I started to use for my foundation and for my life as well, I define aesthetic number. There should be AEs. I'm sorry for anyway, aesthetic numbers, right? And so we have aesthetic numbers 1 to 1, which is the 1221. Also, it's 11 squared. And all these numbers you can see there, right? These are like a first-order aesthetic. I define second-order aesthetic numbers. Why is it? Upfront given aesthetics numbers. 444, a very special one. 777, we'll see in a while. So now let me just one small formula here, just for you to see that we will use later. Imagine that we have that we are drawing a random three-digit number. Yeah. What is the probability that the random three-digit number falls into the category of aesthetics numbers? Right, we had it defined there. So if we have one draw, it would be 7/900 because there is 900 three-digit numbers. If we are drawing three random numbers out of the three-digit ones. Yeah. So what is the probability of selecting at least two first order and one second order, or better? Here is the calculation. It is not difficult, but the probability is relatively small. That out of 3 trials, we chose 3 aesthetic numbers. So then 1221, as I said, was fixed as the unique pair. And a few years later, I learned about Sheldon's theorem. Have you heard about Sheldon's theorem, anybody? It is a connection between 12, 21, and prime numbers. So what we are having here, 21 is mirror of 12, 37 is mirror of 73, and 12th prime is 37, and 21st prime is 73. Okay, so think about it. We have 12, 21, and we have corresponding primes, and the primes, by coincidence perhaps, or not, are 37 and 73. That's called the mirror property. And on top of that, we have 3 times 7 equals 21. That's called product property. And Sheldon's theorem says that this intrinsic connection and feature is unique in a sense that there is no other number in decimal system that would have this property. It was proven in January 2020 by using computers. And this property, the mirror and product, are very, very nice and very special indeed. I can show you our point here. The next first prime greater than 73 that would have the mirror property is this huge number. Yeah, which is where it is palindrome, the prime is palindrome, and also the order of the prime, which is 8 millionth prime, approximately also palindrome. That's why it's the mirror property. It's in fact less nice mirror property than we have here. Here we have different 12 and 21. Yeah? See, so these are no. And for primes lower than 10 to the 10th power, the only instance other than 17 and 21st prime 73 is this prime 2 million, etc., which has the product property, as you can see there. So both the product and mirror property are very unique. Okay, and indeed for 1221, 3773 is the only in the decimal system that are like that. And now comes well, first of all, what is the likelihood that for a given pair 1221, we have something like Sheldon theorem, connection to the prime, which again was out of sample. It's not something that I found and after came with 1221. It was first 1221 came and then the Sheldon's property. It is absolutely unique. It is great. I do not dare to estimate the probability there because, of course, you can have you have large sample space. You can have different features that you find, but still the probability is low. It's very special. I am not aware of any other pair of numbers which would have unique properties in mathematics. So it's the Sheldon one. But nevertheless, now we have this 3773. So what is the next step? The next step is extending second generation of aesthetic numbers, right, using the 37 and 73. So what did we do before? We did 12 to the fourth power. We did 12 times 21. So obviously the next generation of aesthetic numbers is a product of these combination, 12, 21, 37, 73. And what comes now, how the product looks like. This is the art. This is one of the art coming. So look, we have the square, 12 times 37, 444. The first order aesthetic number. 12 times 73, 876. 8 plus 7 plus 6 is 21. That is the second order aesthetic number. 21 times 37 is 777. First order aesthetic number. 3 times 7, 21. And as I was showing the previous one, the probability of this happening by chance is very low. Now, indeed, here, this is not rigorous because we can hardly claim that we have independent trials. Yeah? So for mathematicians, this is not like a precise statement. It cannot be done precisely. But nevertheless, we are in the order of 1 in million for this being by chance. In fact, the last product, which is not there, 37 times 73, is also very interesting. Yeah, but it's not on the first side, but it is also unique. And by the way, 37 times 73 is also very special. So all the products are special, and the 37 times 73 we can maybe look at the end. So, okay, so we have these products as aesthetic numbers, great coincidence maybe, and another step into searching for aesthetic for art in mathematics. We have 1, 2, 3, and 7, right? 4 digits. What is a 3-digit, very second-generation special aesthetic number? If you go through it a little bit, we don't have that much time here, but you will find out is the number prime again, 271. Why 271? Because what is missing there? We are missing 3 to the group of Sheldon theorem. We are missing 3, but 3 is so much beautifully encoded. And 271, look, 3 is 2 plus 1, 21 divided by 7, 7 minus 1 over 2, 2 plus 7, square root of 2 plus 7, and third root of 27. Again, very nice combination. I am not estimating probabilities here, but this is also very special. So we are getting a unique number, 271. So now, I will not ask you, but maybe you can think about a question. Imagine two theoretical mathematicians or theoretical physicists who are asked to give you the most important or most special irrational number. Which one would you choose? What would that be? And I am intentionally saying theoretical mathematicians because if you are, for most people, like non-mathematicians, it would probably be pi, right? But you can think of what would you choose. And I mean, this is not the most important, it's not a rigorous question, but there can be done rigorously. Imagine that you have two mathematicians and they get the prize if they choose the same most important irrational number. The most unique. They get the prize, right? So here we have a rigorous question. Now, what would be, anybody wants to share his his irrational number? Or you can write down, you can see well. So I dare to say that it will be irrational number e, right? The base of natural logarithm, derivative e to x being e to x. So, and again, here we came systematically, without many trials, systematically to a special three-digit number 271. This three-digit number is the first three digits of E, probability 1 to 900 approximately. Okay. Another step, again, we are continuing with our strategy, with our aesthetics numbers. We define what is aesthetic. Square, of course, of 271. That's the first thing that we would try, the natural operation, like multiplication. What we are getting, 73,441, while 441 is 21 squared. So look at it. We just got, dig out, it is about notation. It is actually not about math at itself, right? It is about notation, about decimal system. So we found 271, and the square is again so unique, we are getting 7321 squared. Probability of that happening, the 73441 is again the aesthetic number of 5-digit. There is less than 42 like these, so probability being again 1 in a few thousand. Now, and most interesting, what is coming now is inverse. If you take a prime number. If you have a large prime number and you take this, its inverse, it will have a period. How long the period will look like? Well, if you have a prime number of size p, the period will be in order of p, maybe average p over 2. There are many prime numbers that have a length of period p minus 1. 1 over p has a period length p minus 1. In fact, under as assumption, it's not rigorously proven, we expect that around 40% of primes, when doing the inverse, have a length of p minus 1. So if you take a number like 271, you would expect that the inverse has a length of period 270 or in this order. Well, for 271, we have this uniqueness, and in fact, my conjecture is that it is in some sense shortest, that 271 is the largest number that has such a short period as 5 of its inverse, and it is 00369. Exceptionally short period. This is something that I could see again, because again, it's a systematic approach. It's not that we have large sample space, trying many things, and in retrospect, confirming what we found. This is all step by step getting there. So when I found this as a mathematician, I was so intrigued and so happy about it. Yeah, and it is new. This 271 is actually quite new. I found it not so long ago, a few years ago, and I have played with that. And a year ago, I would show this to my friend. kind of presentation, and I showed him the inverse of 271, and he got completely like how do you say? He said I was like totally shocked. And and you can see, actually, by the way, side note, 270, for those who are not that intrigued in inverse, you can see 271 times 369 is 5 nines. Yeah, so it's this is a consequence of the previous 271 to the inverse. My friend was totally baffled by that. And the reason being, you can see if you type in Google Nikola Tesla number, do you know what you will get? What will step out? It's the number 369. So Google says that 369 is the number that Tesla was obsessed about and stuff. It is probably, it's probably not even true. Yeah, the Tesla was obsessed about 9, but not necessarily. There have been stories created how Tesla used different frequencies of 369. Maybe it's not true, but nevertheless, it is a fact that if you in Google Nikola Tesla number, you will get 369. So, what is the probability of that? Right, coming, creating this, and then coming back in loop, connecting to Nikola, I don't know. To me, this is amazing, fascinating, and it is what it shows. Again, this was not a huge number of trials, trying million things. He would have done billions of things, and through it's called apophenia, that people find relations among numbers and things which are not there, because they are using many trials, and that's how they get there. But no, this was a step-by-step logical approach with no cheating, so to speak, no statistical cheating. And so here I can say a theorem that the probability of, I define actually a random creation. Random creation being that we appeared randomly. And random creation means that all the things that we see our reality are subject to, let's say, physical laws, right? If you have a dice and it is unbiased, you roll it, each number will fall with probability 1/6. Or dodecahedron will each number roll with probability 1/12. And if our appearance here was supposed to be random, then the things that we observe would have to satisfy law of large numbers and all the mathematical properties. So, from what I showed you, using only the explicit parts of calculation, I didn't estimate the probability of Sheldon theorem. I didn't estimate the connection 271 times 369. Even without that, the probability is is in the order of 10 to minus 15. In fact, it would be even lower if we consider the other features. So, to me, this is, it would have been an eye-opener to me. If 30 years ago, when I was here, it would really click my mind. I said, oh, my philosophy is wrong because this cannot be by chance. So I am happy to present it to as many people. Maybe it might help somebody to in this process of, because I believe that it is important for each of us to have own life philosophy, own meaning of life, and search for that, actually. Search for the things that make sense and that we can create and also support each other as people, as on the planet Earth. So here are the wrap-up, what I just talked about, right? It's these nice properties that are there, that are artistic, or it's a signature, as I wrote it, and I really love it because it's just special. It's beautiful. I believe that for our world, the kind of something uniting us is things that make sense and that are beautiful. Right? We are in this evolution where we are on a balance between total chaos. Total chaos would be wrong; we would just get dissolved. Or rigorous, precise rules, which could be too much, right? We do not want to have precise rules only. We want to have some space for art, for extension. So our life is like, to me, it's a balance. It's finding the right balance between randomness, between chaos, and between order and logic. So here is an example of how mathematics, which is a fixed thing, it's a given. It is independent of any philosophy. It is not a religious book which people write, which is open to skepticism. These are numbers that anybody can verify and nobody can dispute. These numbers, which is the rigorous, precise part, how it's connected to the, let's say, abstract, artistic part of our existence. And by the way, the 37 times 73, I mentioned also this interesting. Look, the 271 is again there. We just need to. Usually, if you can, there is zero, so it's there. All this is. All this art comes from the fact that we are using decimal system, right? It wouldn't. The Sheldon theorem is base dependent. This is because of our base, 10 base system. Why 10 fingers then? My conjecture in that is that if we, and I'm sure we make it, we make our evolution will be successful in this birth process of planet Earth, which is full of conflict. But we'll make it, and if we make it, and if we manage to connect as human beings and support each other and go further, we will for sure meet other civilization. And my conjecture would be that other beings, intelligent beings in the universe, will also have 10 fingers. Because if we didn't have 10 fingers, we wouldn't use 10 base system. We would probably use whatever. If there was no number of fingers, probably 12 or 6, right? And there would be no Sheldon theorem. Okay. So thank you so much for listening. I'm happy to any questions or discussions or even objections.
Thank you for the talk. I met Tim. I teach in the math department here. So, low probability. When a low probability event happens, it never surprises me. Right? Because low probability events happen all the time. And in particular, my favorite example of this, everybody pick a fraction between 0 and 1. Just pick one out of the top of your head. All right, everybody got something in mind? The probability you were going to pick that is 0. All right, so probability 0, but the number you picked, you just picked it. So low probability events just never surprise me. Yes. Doesn't mean that there aren't wonderful coincidences in what you're doing, but what you're talking about. So I do think it's interesting. So thank you.
Yeah, thank you. Mm-hmm. Yeah, I absolutely agree. Of course, the low probability events happen if we have sufficient number of trials, right? So if there is a probability of 1 in a million, and we have a million trials, our probability that it will happen is 1 to e, by the way. Okay? If you have probability 1 over n and you have n trials for large n convergent to infinity, the probability that you will make the special case is e2 minus 1. It's 1 over e. It's quite interesting. So yes. So but that's why I was stressing. I was stressing at the beginning what was fixed in advance, right? I came to number 12 and 21. And yes, I didn't go into detail how I got to it. For me, it was important. It was fixed, right? So here, all the other things were again out of sample follows of that. So for example, let's say that if you say that we pick a random number between 1 and million. What is the probability that it will be 951,387? Well, it's 1 over million. But once we do that, we make a random choice. It is not special. Each number has the same probability. what would be, and it wouldn't be even special if we make this random choice, and then in retrospect are finding theories and combination how we could get to that number. Because you can, in backwards induction, we can kind of statistically cheat ourselves to have to find, for example, if we pick a number 2, 4, 6, 8, 10, or whatever the number of digits, then we say, oh, this is very special. Yeah, but this is the statistical problem that we define the uniqueness of the aesthetic after the fact, after choosing it. But here, in what I showed is that the aesthetics was defined up front. So if I defined aesthetic numbers up to 1 million, and I define them up front, and I said one of the aesthetics numbers is 777777, yeah, or like 66666, and then I make the choice, and I indeed choose this upfront selected aesthetic number, which might be, which if it was 177777, and I randomly choose that, then it is a very unique thing. This is so maybe I got for these numbers we can do statistical tests. My argument is that the low probability is after the fact, after I design the experiment and set it up, and then I make the random choice. It is not totally rigorous because we got the products like the 21 times 37, and those are not randomly generated numbers. Yeah, they are in some sense randomly generated for us because we came for it. So this is not completely rigorous. But the argument of having many trials is actually involved in that. We argue that. Yeah. Thank you.
So I'm Professor Amit Sinha from finance. So Matt was from mathematics. Why would finance be behind? You had made a connection that this art in mathematics reinforced your faith, or some words to that effect. Would you elaborate on that?
Reinforced me?
Your faith, your belief in God, and
yeah, actually. Certainly, when this happened, and it was, I didn't know that. This is relatively new, but it was in 2007, and I would design tests more myself. So I would say, okay, and then I could see synchronicities happening, which I cannot share. But it doesn't make sense because everybody can do that, and then it's already subject to random things happening if you have enough trials. But for myself, I could do that, and this was like for me, wow, a total change in my approach to life, and actually it improved it a lot because suddenly life makes much more sense than if it was only random evolution. And yes, so it gave me the trust, I call it trust in the meaningfulness of our being. That's what I strongly believe now, that our being here has a deeper meaning than just random evolution. And I came to that. We can call it belief in universe, God, or something more. Yeah.
This was a fascinating conversation and a wonderful presentation. So let's give a big round of applause to Karel.
Thank you. Thank you. Thank you.